SpaceX launches twice a week. Blue Origin, just a few flights per year. Starship is already the biggest rocket ever built, while New Glenn hasn't even launched yet. For years, SpaceX dominated every metric that mattered, but something just shifted. Blue Origin upgraded their BE-4 engine to 290 tons of thrust, beating SpaceX's current Raptor 3 at 280 tons. This is the first time in years Blue Origin has actually surpassed SpaceX on raw engine power. So is this the beginning of SpaceX losing ground, or does Musk have something up his sleeve? Here's why this engine battle matters more than you think. When it comes to rockets, the engine is where companies burn through the most cash. NASA spent over $2 billion developing the RS-25 engines for the Space Shuttle and SLS. SpaceX poured so much money into Raptor development that Elon Musk admitted it nearly bankrupted the company. Blue Origin has invested hundreds of millions into the BE-4 program, and for years it looked like that investment wasn't paying off. So what changed? Let's rewind to where this rivalry actually began. When the BE-4 first debuted, it produced 250 tons of thrust. At the time, SpaceX's Raptor 1 was only pushing 189 tons. Blue Origin was ahead, and it seemed like they had the superior engine. But SpaceX doesn't stay behind for long. Raptor 2 jumped to 230 tons, getting closer. Then came the real shock. In 2023, SpaceX revealed Raptor 3 had hit 269 tons of thrust, crushing the BE-4 for the first time. By 2024, they pushed it even further to 280 tons. Blue Origin had lost the lead. Did they have any way to fight back? That's when Blue Origin's engineers went back to the drawing board. They didn't redesign the entire engine. Instead, they focused on one critical system: propellant subcooling. By cooling the methane and oxygen to even lower temperatures before they enter the combustion chamber, the engine can handle significantly higher pressures and thermal loads without breaking down. This wasn't just a minor tweak. It fundamentally changed what the BE-4 could handle. The result? 290 tons of thrust, reclaiming the top spot from SpaceX. But here's the question. Is raw thrust really the metric that decides who wins this race? Blue Origin didn't stop with just the booster engine. They're also upgrading the vacuum engine used on New Glenn's second stage. The original version produced 145 tons of thrust. The new variant? 181 tons. That's a massive jump. Blue Origin has already test-fired engines producing over 211,000 pounds of thrust, roughly 96 tons per engine, on their test stands. These aren't just paper specs. They're proven numbers. And when you look at the bigger picture, Blue Origin is planning an even more powerful version of New Glenn. The current design uses 7 engines on the booster and 2 on the upper stage. The upgraded variant would increase that to 9 engines on the booster and 4 on the upper stage. If that configuration becomes real, the first stage thrust could exceed 2,600 tons, with the second stage pushing over 380 tons. That's a rocket that could genuinely compete with Starship's payload capacity. So, does this mean Blue Origin is about to overtake SpaceX? Not exactly, and here's why aerospace engineers aren't panicking about this news. Thrust is important, but it's only one number in a much bigger equation. Raptor has advantages that don't show up in simple thrust comparisons, and some of those advantages matter even more than raw power. Let's talk about chamber pressure. This is where things get technical, but stay with me because it's crucial. Raptor 1 and Raptor 2 operated at around 300 bar of chamber pressure. Raptor 3 pushed that to 350 bar. The BE-4, it sits at around 140 bar. Why does this matter? Higher chamber pressure means you get more performance per kilogram of engine mass. It allows the engine to be smaller and lighter without sacrificing capability. That's why Starship can pack 33 Raptor engines into its booster stage. New Glenn physically can't do that because the BE-4 is larger and operates at lower pressure. Space is limited on a rocket, and if your engines are too big, you can't fit enough of them to maximize performance. Does size really matter when you're already winning on thrust? Here's where it gets even more interesting. SpaceX has repeatedly stated that Raptor 3 is not the final version. They're already working on Raptor 3X, and eventually Raptor 4, which is expected to exceed 300 tons of thrust per engine. When you multiply that by 33 engines on Super Heavy, you're looking at total liftoff thrust exceeding 10,000 tons. That's more than 3 times the thrust of the Saturn V, the most powerful rocket ever successfully flown before Starship. Blue Origin's 290-ton BE-4 is impressive, but when New Glenn launches with 7 engines, that's only around 2,030 tons of total thrust. Even the upgraded 9-engine version would hit about 2,610 tons. Starship's numbers are in a completely different league. So is Blue Origin's engine victory actually just a temporary win? There's another factor most people overlook: production speed. SpaceX is manufacturing Raptor engines faster than any rocket engine has ever been built in history. They're producing multiple engines per week at their Hawthorne factory. Blue Origin is scaling up BE-4 production, but they're not anywhere near SpaceX's pace yet. ULA has been waiting years just to get enough BE-4 engines for their Vulcan rocket program. New Glenn's first launch keeps getting delayed, partly because engine production hasn't caught up to demand. If you can't build engines fast enough, it doesn't matter how powerful they are. Your rocket stays on the ground. Can Blue Origin solve their production bottleneck before SpaceX runs away with an insurmountable lead? But while SpaceX and Blue Origin are pushing boundaries and setting new records, there's another company that's completely falling apart. Boeing's Starliner program has become one of the biggest embarrassments in modern spaceflight. NASA paid Boeing $4.2 billion to develop Starliner. That's $1.6 billion more than what NASA paid SpaceX for Crew Dragon. Yet, SpaceX finished first, has flown multiple successful crewed missions, and has become NASA's primary way to get astronauts to the International Space Station. Boeing, despite the extra money and extra time, has recorded over $1.5 billion in losses on Starliner alone. How did Boeing mess this up so badly? The most recent disaster happened during Starliner's crewed flight test. 2 astronauts launched to the ISS, and everything seemed fine at first. But once they reached orbit, serious problems started appearing. Out of 28 reaction control thrusters on Starliner's service module, 5 suddenly stopped working during the approach to the space station. These thrusters are critical. They control how the spacecraft rotates and positions itself for docking and re-entry. Losing 5 of them is not a minor issue. On top of that, engineers detected 5 separate helium leaks in the propulsion system. Helium is used to pressurize the fuel lines, and if too much leaks out, the thrusters can't get the fuel they need to fire. One leak became so severe that Boeing had to shut down an entire section of the propulsion system just to prevent a complete failure. Can you imagine being one of those astronauts, watching your spacecraft fall apart around you? It got worse. Engineers found unusual temperature spikes in some propulsion components, and there were concerns that the thrusters were overheating. NASA later confirmed that several thrusters showed signs of erosion and wear after only a short time in operation. That's not supposed to happen. These components are designed to last through multiple missions, not degrade during the first flight. There were also problems with the wiring and sensors inside the service module. Some sensors were giving inconsistent readings, making it harder for NASA to trust the data coming from the spacecraft. The biggest fear: a propellant leak during re-entry. If a thruster valve failed or a leak expanded at the wrong moment during the descent back to Earth, the astronauts could lose control of the spacecraft entirely. That's a nightmare scenario. So what did NASA do? They made the call that nobody at Boeing wanted to hear. The astronauts would not be returning to Earth on Starliner. Instead, NASA arranged for SpaceX's Crew Dragon to bring them home. Boeing's spacecraft, the one that cost $4.2 billion and was supposed to provide NASA with a backup option, ended up needing to be rescued by its competitor. That's not just a technical failure. That's a complete collapse of credibility. Boeing was supposed to be the experienced, reliable contractor. SpaceX was the newcomer, the risky bet. But now SpaceX is the one NASA trusts, and Boeing is the one struggling to keep up. After this disaster, NASA canceled Starliner's next crewed launch. The program isn't officially dead, but it's on life support. How much longer can Boeing afford to keep losing money on a spacecraft that doesn't work? So here's what all of this really means. Blue Origin's BE-4 upgrade to 290 tons is impressive, and it shows they're finally competing seriously. But beating SpaceX on one metric doesn't mean winning the war. Raptor still dominates on chamber pressure, production speed, and total system thrust. SpaceX is building engines faster than anyone in history and already flying the most powerful rocket ever made. Blue Origin is catching up, but they're still years behind in actual flight experience and manufacturing scale. And then there's Boeing, which spent more money than SpaceX, took longer, and still couldn't build a spacecraft that works. That's the real story here. The space industry is splitting into two groups: companies that move fast, iterate, and actually fly their hardware, and companies that spend billions on programs that barely leave the ground. SpaceX isn't slowing down. Blue Origin is accelerating. Boeing is collapsing under its own weight. The question isn't whether Blue Origin's engine is better. The question is whether they can turn that engineering win into real rockets launching real payloads before SpaceX moves even further ahead. Right now, SpaceX launches twice a week. Blue Origin hasn't launched New Glenn once. Until that changes, the engine numbers are just numbers. If you want to stay updated on how this space race unfolds, hit that subscribe button and join New Space Review. Drop a comment on who you think will dominate the next decade. Like this video if you learned something new, and share it with anyone who's following this competition. Thanks for watching, and I'll see you in the next one.